Okay, what statement can you conclude to be true? Let's take a look at what we know. We know that AB, this line right here, is the perpendicular bisector. That is bisecting IK, means splitting it into equal segments. And then we know that any point on this line, like A, for example, is the same distance to the endpoints there and there. So that's the same distance there and there. So I'm going to sketch some stuff out that we know to be true. Let's say this right here and that have the exact same measure. And we know that that, sorry, uh, this line, sorry, is there. And then we know that this line and that line have the same measure. We also know, let me just get my black pen here. So we know that that is congruent to that. We know that that is congruent to that. And of course, since IK is being bisected, we know that that is congruent to that. Yeah? Excuse me. So, and of course we know that there are right angles down here, right there. So, let's see. AJ is congruent to BJ, AJ is congruent to BJ. No, actually we don't know that. There's no reason to think that this length is the same as this length. A could be anywhere along that perpendicular bisector. It doesn't have to be the same distance from J as B is. Okay? So we don't know that to be true. IAJ is a right angle. IAJ, now that's that. We know that that's definitely not. If this is a right angle, then this has to be less than 90 degrees. Otherwise, these two angles together would take up the whole 180 degrees, and it can't. So this cannot be 90 degrees, so that's false. Okay. IJ is congruent to JK. IJ, JK. Yeah, we know that AB is bisecting IK. AB is bisecting IK, so that means that this length is equal to this length. So we know that that's true. And A is the midpoint of IK. A is the midpoint? No, midpoints are on the line. And A is not on the line IK. IK is here, A is not even on it. So it can't be true. So there you go.